Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kisiedu. In this installment in the Developmental Mathematics series, I will discuss fractions, part 4, continued fractions and approximations. A continued or chain fraction is a complex fraction whose denominator contains a succession of fractions. Continued fractions are useful in obtaining close approximations to a given fraction that are expressed in simpler terms than the given fraction. This continued fraction is equal to 15 over 62. To convert a continued fraction into a proper fraction, start at the bottom fractional denominator and add. Working upward from the bottom of the continued fraction that we just saw, since 7 plus a half is equal to 15 over 2, 1 over 7 plus a half is equal to 1 over 15 over 2, which is equal to 1 times 2 over 15, multiplying by the reciprocal of that last fraction. The summing result is 2 over 15. Then, 1 over 4 plus 2 over 15 is equal to 1 over 4 times 15 plus 2 all over 15, which is equal to 1 over 62 over 15. Simplify this complex fraction by multiplying by the reciprocal of 62 over 15 to get 15 over 62. As a simple example, let's write this continued fraction as a proper fraction. Starting at the lowest level denominator, 2 plus 1 over 5 is equal to 11 over 5. At the 3 plus 5 over 11 level, 3 times 11 plus 5 over 11 simplifies to 38 over 11, which is equal to 1 plus 1 over 38, or 1 plus 11 over 38. Continuing up through the levels in the same way, the continued fraction is finally equal to 49 over 87. To convert a proper fraction into a continued fraction, first divide both the numerator and denominator by the numerator. Then the numerator of the complex fraction will become 1, and the denominator becomes a mixed number composed of a whole number and a proper fractional remainder. Third, begin again with the fractional remainder by dividing the numerator and denominator by that numerator. Last, continue the process until all fractional denominators have a 1 in the numerator. Given 73 over 142, divide both the numerator and denominator by 73. Simplifying the numerator to get 1, then dividing 142 by 73, you get 73 over 73 plus 69 over 73, or 1 plus 69 over 73 in the denominator. Now, in the second level, divide the numerator and denominator by 69. Simplifying the numerator to get 1, then dividing 73 by 69, we get 69 over 69 plus 4 over 69, or 1 plus 4 over 69. Now in the third level, divide the numerator and denominator by 4. Simplifying the numerator to get 1, then divide 69 by 4 to get 17 plus 1 over 4. Since the numerator of each fraction is 1, the conversion is complete, and 73 over 142 is equal to this continued fraction. We can use continued fractions to find good or close approximations to proper fractions. As we saw in the last example, 69 over 73 can be written as 1 over 1 plus 4 over 69 by dividing the numerator and denominator fractions by 69, then simplifying. If the 4 over 69 subfraction is removed, the fraction that is left, 1 over 1, or 1, will be larger since the denominator has been made smaller. 1 is larger than 69 over 73, but only by 4 over 73, which is the difference between the two. So 1 is a good first approximation to 69 over 73. To get better or closer approximations, we have to expand the continued fraction to further terms. Continuing the last example and starting at the second level denominator, if the 1/4 is removed, we have 1 over 1 plus 1 over 17, or 1 over 18 over 17, which is equal to 17 over 18. We can compare 17 over 18 and 69 over 73 by writing each fraction in terms of the LCD. 73 is prime, so 17 over 18 is equal to 17 times 73 over 18 times 73, or 1,241 over 1,314. And 69 over 73 is equal to 69 times 18 over 73 times 18, or 1,242 over 1,314. For a difference of only 1 over 1,314. So 17 over 18 is a very good approximation to 69 over 73. As a final example, let's find a fraction that approximates pi to 4 decimal places. To 4 decimal places, pi is approximately equal to 3.1416, which can be written as a mixed number as 3 plus 1,416 over 10,000. Expressing 1,416 over 10,000 as a continued fraction, first divide top and bottom by 1,416 to get 3 plus 1 over 7 plus 88 over 1,416. Now, in the second level, divide both numerator and denominator by 88 to get 1 over 1 over 16 plus 8 over 88, which reduces to 1 over 1 over 16 plus 1 over 11. Since all numerators are 1, this is as far as we can go. The first approximation, omitting 88 over 1,416, is 3 plus 1 over 7, or 22 over 7. A difference of 11 over 1,250 from our original mixed number. The second approximation, omitting 1 over 11, is 3 plus 1 over 7 plus 1 over 16, which is equal to 3 plus 1 over 113 over 16, which is finally equal to 355 over 113. A difference of 1 over 141,250 from our original mixed number. Though 335 over 113 is a much better approximation to pi, 22 over 7 is much more commonly used. If we want a better fractional approximation to pi, we would have to start with a decimal approximation with more decimal places. Then we could approximate that with a continued fraction.